Hello students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will start the numerical problems on temporary and permanent hardness calculated in degree French units. So before going to the problems, we have to just have a glance and what are they? Water hardness causing salts. So if you see this picture, this is hard water and this is soft water. Why is it called soft water? Because it is producing lather. Soft water always produces good amount of lather when compared to hard water. It is just because of hardness causing salts that are responsible for suppressing this forming lather. Hardness causing salts. Hardness causing salts. So there are different types of salts that are present due to the anion and cationic species that are present in the water, causing this hardness and avoiding the lather. So what happens if this is used in the domestic and industrial purposes? It will lead to some scale formation. So that will avoid or restrict our daily processes in the domestic appliances or the domestic ware and also the industrial boilers, for example. So there are two types of hardnesses we measure in water. So it is hardness, like temporary hardness and permanent hardness. Why is it called temporary? It can be removed. How is it removed? Like by boiling water. So the salts like bicarbonates of calcium and bicarbonates of magnesium are responsible for temporary hardness. So bicarbonate HCOO3 is the bicarbonate ion, that anion that is responsible for the temporary hardness. So any water will contain large amounts of this calcium, sodium and magnesium. However, sodium is not causing any hardness to water. That is why we are even able to drink the sodium containing sodium chloride. But for example, if there are calcium and magnesium ions present in huge amounts, that causes hardness and gives troubles to the boilers. So that is why we need to remove this hardness before we use it for any industrial purpose as a engineering perspective. So this calcium carbonate, what happens when it is boiling? The effervescence will be coming out, that is due to carbon dioxide escaping out from that water, and it is forming calcium carbonate that is soluble and does not cause any problem to the boilers, causing the scales. And the similar way, magnesium bicarbonate also upon boiling will allow to escape this carbon dioxide, so and it remains the magnesium hydroxide forming that precipitates out. All this calcium carbonate and magnesium carbonate can be removed by filtration. So this is one type of way wherein temporary hardness can be removed, like precipitating and removing it through filtration. Next comes the permanent hardness. Permanent, the name indicates that it cannot be removed so easily. So the causing salts are like calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, iron sulfate or ferrous sulfate, and aluminium sulfate. If we see, very commonly chlorides and sulfates are present. Chlorides and sulfate ions are responsible for the permanent hardness. So these these are the primary responsible anions species that are causing the scales. If you see, sometimes the scales are yellowish in color. That could be because of these sulfates and chloride ions that are present in huge amounts in that particular water. So therefore they cannot be removed upon boiling. Even if we use it boiling, if we see the boiling container is containing the scale, that is nothing but because of these chloride and sulfate ions. So it can only be removed by chemical agents. So before we go for any instrumentation or manufacturing department, we have to understand the water that is used in that should have less hardness. So for that, we will be studying the hardness calculations. So if we go further, there are expressions that is used. So for degree of hardness, it is given in the degree of hardness for any particular water. So it is given by weight of hardness causing salts. So the causing salts, water responsible, the weight has to be taken by in ratio with the molecular weight of hardness causing salt. For example, if we have calcium chloride, weight is x grams and its molecular weight is taken as y grams. So its molecular weight divided by its molecular weight into 100. 100 is nothing but molecular weight of calcium carbonate. Why we are taking calcium carbonate? Because measurement is done in calcium carbonate equivalence. Why only calcium carbonate equivalence? Because this is the most wide calcium carbonate is the that cannot be removed so easily nor precipitated. So large amounts are present in calcium carbonate. That is why all the hardness will be taken in the measurement of equivalence of calcium carbonate. So these are the different salts that are present in water when we try to use hard water. So this is like calcium bicarbonate, magnesium bicarbonate, calcium sulfate, calcium chloride, and magnesium sulfate, magnesium chloride, and so on. We have a lot of salts or ions are responsible for the hardness. So this is nothing but molecular weight. These are the molecular weight. How is the molecular weight calculated? For example, calcium, it is 20. So we will be taking its atomic weight and then adding with this hydrogen, carbon, oxygen weights, atomic weights, and ultimately we get molecular weight. So the equivalent weight or the chemical weight is nothing but half of it, that is 81 is the equivalent weight, and it is multiplied by the calcium carbonate equivalent weight, that is nothing but the molecular weight. So it is taken as 100 by 162. That is how the multiplication factor is done for converting into calcium carbonate equivalence. So then there are a lot of units that are used to express this hardness. So 1 ppm is nothing but 1 mg per liter, milligram per liter. It is also given in the fraction of 0.1 degree French. 0.1 degree French. This is nothing but degree French. Degree French, and is equal to 0.07 degree Clark. Degree Clark. So these are some of the units that are used to express the hardness. And 1 degree Clark is equal to 1.433 degree French, that is equal to 14.3 ppm, that is also 14.3 milligram per liter. So 1 degree French is equal to 10 ppm. So if we see either here or here, if we see 1 degree French is equal to 10 ppm is equal to 10 milligram per liter, it is also converted to degree Clark like 0.7 degree Clark. So if we want to convert 1 ppm or 10 ppm, 1 degree French, it is multiplied with 0.7 to get degree Clark. So this is how we will be using the conversion factors to get our desired units. So let us jump into the problems that are actual problems we'll be dealing with the hardness. So a sample of water is found that contains following analytical data in milligrams, wherein liter of water is taken. So milligrams per liter is nothing but ppm. So it is given in ppm. All the values are in ppm or milligram per liter. So magnesium bicarbonate is equal to 14.6. and magnesium sulfate is 6 ppm and calcium bicarbonate is 16.2 ppm. So what we have to really do, calculate the temporary and permanent hardness of water in parts per million and degree French. ppm and degree French. So that is what we have to calculate. So moving further, we will be using this formula. Degrees of hardness is equal to weight of the hardness causing salt by molecular weight into 100. So this weight is nothing but, for example, this is 14.6. 14.6 is taken by the molecular weight of magnesium bicarbonate. So like that, the amount of hardness, let us keep it in a table like that so that it's easier for the calculation. So 14.6 is the magnesium bicarbonate, 9.5 or 6.0 is the magnesium sulfate, and calcium bicarbonate is 16.2. So after that, we will be taking the molecular weights of that particular salts, hardness causing salts, that is 146 for the magnesium bicarbonate, 95 for the magnesium chloride, and magnesium sulfate 120, and the calcium bicarbonate is 162. We have to either remember these molecular weights or calculate during the formula, during solving these problems. So after that, we have to convert to the equivalence of calcium carbonate. That is just like dividing. So this 100 divided by molecular weight of that particular salt into weight. You can take in either ways. So the same thing is done here. 14.6 into 100 by 146 is equal to 10. So that is how we get the amount of equivalent of calcium carbonate. It is like equivalent of calcium carbonate that is present as a hardness. So for calculating the temporary hardness, like we have seen, the bicarbonates of calcium and magnesium are responsible for the temporary hardness. So what are the salts present here? Bicarbonates of magnesium and bicarbonates of calcium. So 10 plus 10 magnesium and bicarbonates of calcium. So temporary hardness 10 plus 10 is equal to 20 milligram per liter or 20 ppm. 20 milligram per liter or 20 ppm. So we have to convert to degree French. Then multiply with 0.1 degree French is equal to 2 degree French is the hardness, temporary hardness that is present. So for permanent hardness, what are the salts that is causing permanent hardness? Chlorides and sulfates that are present in the water. So what are the chlorides that are present? Magnesium chloride and magnesium sulfates are present. So magnesium chloride is 10. This is permanent hardness. So, yeah. 10 plus 5. So, 15 milligram per liter or 15 ppm. Again, for converting into degree French, it is 15 into 0.1 degree French and giving rise to 1.5 degree French. So, the temporary hardness is equal to 2 degree French. And permanent hardness is equal to 1.5 degree French. So both are like equally they are present. This can be removed by boiling. This has to be done by chemical reagents or chemical agents or reverse osmosis or ion exchange process. So the different ways that can be used to remove the permanent hardness. Next is like calculate the amount of temporary and permanent hardness of a water sample in degree Clark's, degree French and milligram per liter, which contains the following impurities. So there are bicarbonates present. Calcium bicarbonate, it is 121.5 ppm. Magnesium bicarbonate 116.8 ppm. Magnesium chloride 79.6 ppm and calcium sulfate 102 ppm. So now what is the formula to be used? Degrees of hardness, that is given as weight of hardness causing salt by molecular weight of hardness causing salt into 100 to get equivalent of calcium carbonate. Now put it in the table. Calcium bicarbonate, magnesium chloride and calcium sulfate. So what is the concentration that is present? Amount 121.5, 116.8, 79.6 and 102 ppm. So what are the molecular weights? Again 162, 146, 95 and 136. Now multiply with the take the equivalent like 100 by 162 the molecular weight and we get 75. Then multiply with the amount that is present and we get the amount in like 75 for the calcium bicarbonate and then 80 for the magnesium bicarbonate, then 3.37 for magnesium chloride and calcium sulfate is 75. So this is expressed in equivalence of calcium carbonate. So if we see what are the bicarbonates present, these two are bicarbonates that are present. So they are temporary hardness causing temporary hardness and these two are permanent hardness. So now we will calculate the amount of temporary and permanent hardness present in that particular water sample. Temporary hardness by the bicarbonates of magnesium and calcium. So 75 plus 80 is 155 ppm and milligram per liter, or ppm is same. So 155 ppm, and that is converted to degree French by multiplying with 0.1 factors. So that is the present amount, 15.5 degree French. Then is the permanent hardness causing due to chlorides and sulfates of the metal ions or the alkali metals. So magnesium chloride plus calcium sulfate is 3.37 plus 75, giving rise to 78.37 ppm, or milligram per liter. So it is 78.37 into 0.1 will give rise to 7.81 degree French. So these are the temporary and permanent hardnesses that are present in that particular water sample in degree French. So permanent hardness is 7.84. If you see this sample, the permanent hardness is low when compared to temporary hardness. So before moving to permanent hardness removal, we have to boil the water and try to remove the temporary hardness, so as much as hardness can be removed in the boiling itself. Next, a water sample is found to contain the following dissolving salts in milligrams per liter. Milligram per liter, that is nothing but ppm. Again, ppm. So magnesium bicarbonate is having a concentration of 16.8 ppm, and magnesium chloride is 12 ppm. Then magnesium sulfate is 29.6 ppm, and sodium chloride is 5 ppm. So determine the temporary and permanent hardness of the water sample in degree French. Degree French. So this same formula will be used. Degrees of hardness, weight of the hardness causing salts by weight, molecular weight into 100 molecular weight of calcium carbonate to get it in the equivalence amounts of calcium carbonate, and we will put it in the table. As we know that sodium chloride does not contribute to any hardness, that will not be considered in the calculations. So magnesium bicarbonate is having 16.8 ppm, and magnesium chloride is 12, and then magnesium sulfate is 29.6. Even though sodium chloride is given by the examiner in the problem, it is just to confuse the student. So do not worry about the sodium chloride. Just do not ignore that in the calculations. So only the bicarbonates of the calcium magnesium salts and chloride and sulfates ions of salts of calcium bicarbonates will cause hardness to particular water. Then molecular weights are 146 for magnesium bicarbonate, then 95 magnesium chloride, and magnesium sulfate is 120. So now divide this equivalent to get equivalent of calcium carbonate. 100 divided by 146 of this molecular weight will give the equivalent, and multiply with the concentration that is present in the water to get 11.5. So if you see, do the similar thing for all the three salts that are present. So the bicarbonates will cause temporary hardness. Then magnesium chloride and magnesium sulfate will cause permanent hardness to the water. So accordingly, we have to use it for the further calculations. So if you see, there is only one salt that is present for the temporary hardness. So that is magnesium bicarbonates, that is 11.5 milligram per liter, or ppm. That is like converting 11.5 into 0.1 is 1.15 degree French. Then for the permanent hardness, magnesium chloride and magnesium sulfate are responsible for the permanent hardness present in that water. So 12.63 plus 24.66 will give rise to 37.29 milligram, or ppm present concentration in the water. So that is again converted to degree French by multiplying it 0.1 degree French to obtain 3.729 degree French. So what is the permanent temporary hardness present? It is 1.15 degree French, and permanent hardness present is 3.729 degree French. So here in this sample, this is low and permanent hardness is high when comparing to both the hardnesses. So the treatment is compulsory, like after boiling the water, the further treatment is compulsory, because the permanent hardness is very, very high compared to temporary hardness. Next, a sample of water gives an analysis like 13.6 milligram per liter of calcium sulfate and 7.3 milligrams of magnesium bicarbonate. Now calculate the total hardness present, permanent hardness present in degree French. So what are the salts that are causing for permanent and temporary hardness? We should have an idea. Then use this formula: degrees of hardness, weight of hardness causing salt by molecular weight into 100 to obtain in the equivalence of calcium carbonate. Now calcium sulfate is, how much is it? 13.6 milligram per liter, and magnesium bicarbonate is, O is capital, magnesium bicarbonate is 7.3 milligram per liter. So now the molecular weight is 136 and 146 for the magnesium bicarbonate. Now get the calculations like 13.6 into 100 by 136 is equal to 10, and 7.3 into 100 by 146 is equal to 5. So this is again used for the calculation for temporary and permanent. To get, now here in the question they have not asked temporary hardness, but still we have to calculate, because for getting total hardness is nothing but total hardness is equal to temporary hardness plus permanent hardness. Even though the problem does not contain temporary hardness, we have to calculate temporary hardness in order to obtain the total hardness. So temporary hardness causing salt is only like bicarbonate that is present, magnesium bicarbonate. So that is 5 milligram per liter or ppm. So that is again converted to degree French by multiplying with 0.1 degree. So it is giving 0.5 degree French. So permanent hardness is calcium sulfate. There are only two salts that are present. So calcium sulfate is causing the permanent hardness, having a concentration of 10 milligram per liter or ppm, and this is again converted to degree French by multiplying with 0.1 degree French. So it is giving 1 degree French. Now the total hardness is adding the both temporary and permanent hardness. 0.5 plus 1 is 1.5 degree French. The total hardness that is present in that particular water is equal to 0.5 plus 1.0, that is 1.5 degree French. This is the total hardness that is present in that particular water. Next, calculate the temporary and permanent hardness of water in degree French containing the following dissolved salts. So the salts that are having are calcium carbonate 50 mg per liter, magnesium chloride 9.5 mg per liter, calcium chloride 2.2 mg per liter, and magnesium sulfate 12 mg per liter. So again, if we see here, calcium carbonate is insoluble salt, so it does not cause hardness, and is given calcium carbonate is given as a hardness causing salt. So it must be considered, like if at all it is given in the as a hardness causing salt, it should be a bicarbonate. So the bicarbonate hardness has to be considered, whose hardness is to be expressed in calcium carbonate equivalent. So calcium carbonate, if it is taken, like the quantity whatever is present, 50 mg per liter, again put it in a table. Calcium carbonate is 50 mg per liter, magnesium chloride is 9.5, then magnesium sulfate is 12 mg per liter, and calcium chloride is 22.2, and their molecular weight 195 for the magnesium chloride. Magnesium sulfate is 120, then calcium chloride is 111. So now the equivalent of calcium carbonate is 50, and then the equivalent of calcium carbonate for the magnesium chloride is 9.5 into 100 by 95, that is giving rise to 10. And next, magnesium sulfate is 10 and calcium chloride is 20. Now let us consider what are the permanent and temporary causing hardness salts here. So if we see, the calcium chlorides and the magnesium chlorides are responsible for the permanent hardness. So this will cause permanent hardness. So the temporary hardness is only just because of calcium carbonate, that is only 50 mg per liter or in ppm. and after converting like 15 to 0.1 degree French is 5 degree French. So that is expressed in degree French. And permanent hardness is hardness of magnesium chloride, calcium chloride and magnesium sulfate that is to be considered. Always remember chlorides and sulfates cause permanent hardness. Carbonates, bicarbonates cause temporary hardness. So 10 plus 10 plus 20, that is 40 mg per liter or ppm. Then 40 into 0.1 multiplied by 0.1 will give 4 degree French. So that is the permanent hardness that is present is 4 degree French. And temporary hardness is 5 degree French. So if we see temporary hardness is high, permanent hardness is low. So both are like equivalent, only equally present. So the most of the hardness will be removed in the temporary hardness because of its higher value, and that will remove by the boiling, and permanent hardness to be removed by any of the chemical agents or through other processes like ion exchange, osmosis, reverse osmosis, etc. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.